Hello and welcome to the third video of the chapter Water. With that being said, let's get started. I'm Ryan, a volunteer from Vidhai in the team Exams Vidhai. Here we are going to study about the chapter Water, which will be important for the exam of NMMS. All the context will be from the 8th standard textbook of the chapter Water, Samachir Board. So let's look at the contents of the video again. So you have this mind map, and every part of this left hand side we have covered in the past two videos, where till question 1, the introduction of water, composition of water, we have covered in video 1. In video 2, we have seen the physical properties, chemical and the universal solvent properties of water, and with some extra questions. Now in this video we'll be learning about potable water. What is potable water, what is its characteristics, and what is the purification of water, and what is hardness of water, we'll be learning in this video. So with that being said, let's move on to the slides. Potable water, let's look at its characteristics. Before going into the characteristics, we probably want to know what is potable water. So what is potable water? The water that is suitable for drinking and for other uses is called as potable water, and this is mainly for drinking purposes. So water suitable for drinking is called potable water. Potable water should be colorless and odorless. So you can see water in many places which has slight brownish color or grayish color. Those are not potable water, but the water that you drink, which is colorless and odorless, that is not foul smelling, is the potable water. Here a boy drinking the potable water, you can see how clear the water is. It's not colored and it's not foul smelling. Here in the water used in the industries, you can see how tarnished the water looks, how gray and how brownish the water looks. It's filled with chemicals. This would also give some odors of chemicals, like harmful chemicals and all, and it's not advisable to go near industries when these waterways are working. And here you have the clean water, which is reflecting like a mirror. It's colorless, it's transparent, and it's probably odorless as well. So these are the main characteristics of potable water. It should be transparent, it should be free of microorganisms, it should be free of impurities, it should be containing some minerals and salts for our basic minerals and vitamin needs. So here is an example, rather an perfect example to show which is not potable and which is potable. So you have a potable water here, like we discussed. It's odorless, it's tasteless, and it's free of impurities, right? But here you have a bottle of Coca-Cola. Here it is transparent indeed, but it's not colorless. It is colored with this red color fizziness, if you see. And this is not potable water. Though it tastes good, it's not potable water. It does not have microorganisms in it. It does not have suspended impurities in it. It does contain minerals. It is almost considering all of these characteristics, but not this characteristics, which is the main that you have to focus. It should be colorless and odorless, which is not. And here's the potable water, which is colorless and odorless. So the minerals that you have to remember to be present in potable water is calcium, magnesium, potassium, copper, and zinc. These are the 5 main minerals that you have to remember. This may be asked in the exam as well. So the next slide for potable water is how do you make potable water from a non-potable water. And through a process called as purification of water. There are different methods of purification of water, and we will be looking one of such. Sedimentation. First, this is a whole process, and now I'm going to explain the sub-process in it. So you have sedimentation, where waters are collected from rivers and lakes into large tanks, and these tanks are called as sedimentation tanks. I'll show you in the next slide how the sedimentation tanks look like, right? So these big rocks and these small pebbles, they'll be left for days, and those will be sedimentated, on the bottom of the tank. Sometimes potash alum is added to water. So what does potash alum do is give weight to these really large or really small boulders. Once you add weight onto them, they'll sedimentate faster. So this is the potash alum, right? It's in solid state. Usually it's added like in a powder form, or when you dissolve this into water, it will dissociate into a powder form as well. Next you have the filtration. Now you take away the top part of the water only from the sedimentation tank, which is free of these big boulders and all, and the filtration is consisted of gravels, sand, charcoal, and probably some concrete as well. So we have these more small pebbles and small impurities that will be present in water of the size of a fingernail. Filtration is the process to remove those size diameter impurities of water. So as the name says, filtration, you are filtering out the impurities from the water. Next is sterilization, and here in these few first points you learn about chlorination. So sterilization is one of the important points that is a deciding factor of whether to say a water is potable or not. The filtered water should be chemical treated. So what does this mean? It means that you are adding chemicals to the water so that it's not at the same time harmful for us to drink it, but at the same time should kill the impurities. And one such chemicals that are used in this process are chlorine and ozone. Chlorine, small amounts of chlorine is not harmful for us human beings, and ozone is the same manner. For ozone, it's called ozonization, where it is exposed to ozone gas, like you'll pump ozone gas into the water to kill germs. As you know that ozone, or for a fact, ozone is a really good oxidizing agent, and when you oxidize the germs, it will easily die. Sterilization of water can be done by exposing air and sunlight to the direct water. So what does sunlight do is kill these germs at really high temperatures and radiations from the sun. So an aeration is the process where air is pumped into the water to kill the germs and bacteria. This is more or less same to the ozonization, because ozone is also a form of gas. Now here's the diagram that I told I will show to you in the previous slide. So you have the sedimentation tank that you will pump in lots and lots of water, and these will be these rocks, really big rocks that will go down and sedimentate. Like in the well, you would rest the well for, let's say, 2 to 3 days, and then you have clear water up, and then you only take up the clear water. Here is the same scenario. So you only take the up water part, the more or less clean part, and take away the sediment part later from this tube. After taking the clean, more or less clean part, you go through this filtration tank where it's layered with charcoal and sand, and then in this down part you will get much more clear water. And then when you filtrate them and give this into this particular pipe, you will go into the chlorination tank. Here you have the chlorine cylinder where it's the source of chlorine. You will pump in chlorine, it will destroy the microorganisms and send in clean water. So in filtration tank, look at the amount of particles like these small pebbles will be taken out, and here you have microorganisms like bacteria, protozoa inside the water, which will be killed by chlorine. So for the last property of potable water, which will determine its potable characteristics, is the hardness of water. So when salt of sulfides and chlorides, right, are present in small quantities in water, it's called as soft water, and when it's in really large quantities, it's called as hard water. So what does these salts of sulfide and chloride mean? So for potable water should be a soft water. If it's a soft water only, soaps and detergents can work to their maximum level. This is often given to the laundry or the washing of utensils kind of. Like I said, potable water is a water that you use for everyday life, not just for drinking purposes. But for hard water, when you use soap and detergents with hard water, you will create something called as a really thick salt PPT, precipitate in short form, called as scum, right? So you have this diagram in the textbook as well. Like you have liquid soap plus lime water, it gives foams, few foams. Like you can this cloudiness being a lot smaller when you compare to this, where this is a rainwater. So the difference between lime water and rainwater is rainwater is a soft water, while as lime water is a hard water. Lime water consists of minerals and many salts. Here's a real life example of hard water and soft water. You see, the cloudiness here is so small when you compare to here. Here you use detergent on here for soft water, you get more cloud than here. So disadvantages of hard water: it's not good for washing clothes, utensils, and when you drink hard water, you will get something called as stomach alignments. It will more or less degrade your digestive system. When you use hard water on machineries, it will reduce the efficiency of machineries by breaking them down. And by scales, I mean is like rust on the iron rod, but scales is much more generalized term on more metallic parts in the machinery. So the hard water salts, if they ask which chemicals is responsible for hard water, it will be either of these two answers, right? Is both of them are right, but for now remember these four names. If any of these four names comes up, that's the right answer for the reason for water being hard. So magnesium and calcium, right, is responsible for hard water, and sulfate and chlorides. So any combination of these four, like magnesium sulfates, magnesium chlorides, or calcium sulfates, calcium chloride, if those types, so there'll be totally four combinations, right? So for four combinations, if any of these combinations one comes inside the options for responsible for hard water, that is the right option. So the next step which we'll ask is, how do we remove the hardness? For temporary hardness, that is not really strong salts are present, right? You can easily remove it by boiling, and when you remove it by boiling, only the salts that are responsible for hardness will be left behind, and the other water and other minerals will be vaporized into the water vapor, and then you can collect the water vapors using condensation and get the clean water. So what you can do next is adding washing soda to it. What does this do is convert the chlorides into insoluble carbonates, where carbonates are not responsible for hardness and can be easily filtered out. So here's the washing soda. It's like a white powder. You can even get it in your local stores. Ion exchange. Here you can do a simple ion exchange resin, where you can drop that resin inside water, or you can filter it through a filtering net to get magnesium or calcium replaced by sodium ions, and sodium ions will decrease the hardness as they are not responsible for hardness and can be also evaporated away. And the next and the most consistent method, rather the important for removing hardness, is distillation. This is used in many of the laboratories to get pure water irrespective of where the water source is. So you got both temporary and permanent hardness can be removed using the method of distillation, right? This distillation diagram I have shown you in the first video of the chapter water. It's under the slide of lab preparation of water. You can check it out later. It's also inside the textbook, so you don't have to worry about it. Now for the practice question of this video. Permanent hardness of water is due to the presence of what from these options? So you have sulfates and chlorides, dust particles, carbonates and bicarbonates, and other soluble particles. Take your time, pause this video and try to answer this question, and then come back to this video. For those who want the answer, continue watching the video. So for the answer for this is sulfates and chlorides. You remember that I've given you 4 elements that are responsible for hardness of water. Those are magnesium, calcium, sulfates and chlorides. So you got to remember these 4 names that are responsible for permanent hardness of water. With that being said, this concludes the part 3 of the chapter Water. Please check the description for more questions and the lecture notes for the chapter Water. All the text I have taken for the slides are from the textbook and textbook only, so you don't have to refer to any other sources. Apart from the images that you see in the slides are from Google. Also remember to go through the points to remember, glossary and all the questions at the end of the chapter. Once again, thank you for attending.